Hello, everyone. Welcome to this week's news and community spotlights. Summer is steadily coming to a close, and you know what that means. It's time to join us to learn, network, and have fun at this year's Unreal Fest Seattle. Sessions will cover games, film and TV, automotive, architecture, real estate, broadcast and live events, retail and fashion, and of course, simulation. Plus, there will be cross-industry and Unreal Editor for Fortnite tracks, as well as hands-on labs. You can learn more about Fest and register at unrealengine.com/events. The ever-improving arts and sciences of real estate technology, or PropTech, continue to evolve the way real estate is developed, designed, marketed, and managed. Vero's recent work on making a digital twin of Amsterdam helped showcase how one of the city's most iconic areas could blend commercial, tech, and urban development with entertainment. Following their talk at Unreal Fest Prague, we chatted with Rustam Karimov, product director at Vero, about how the company evolved into a visual, commercial, and digital accelerator for real estate development, and how the company has used Unreal Engine for the past 6 years in its work. If you're interested in hearing more, you can find the full interview at unrealengine.com/feed. Now, let's get into the spotlights for this week. Iron Eagle Viking by Kudeon, based off of the concept by Pavel Hristov, is a gorgeous character rendering that was shot in Unreal Engine 5. The project page features not only a look at the piece from every possible angle, but also with and without a helmet, as well as extensive breakdowns of individual pieces and parts of the overall 3D model. If you're interested in seeing more, you can do so at their ArtStation. The Reach Cinematic by Enrico Labaril, based off of the beautiful art by Andrew Porter, is a stunning, stylized 3D take on an adventurous and mysterious courtyard. Utilizing a combination of Blender, the Substance Suite, Photoshop, and Unreal Engine, they transport you right into the immersive sands of this little world. Make sure to check out their full cinematic at their page, and you can check out more of their work on their ArtStation. Royal Banquet by Hosan Kim, based off of the concept by Natcha Namfuirat, is a captivating personal project created with the intention of updating their approach to crafting 3D environments. They set out to acquire new skills and learn software they hadn't previously used, such as Unreal Engine, Marvelous Designer, Substance Designer, SpeedTree, Marmoset, and DaVinci Resolve, making for an ambitious and ultimately incredibly well-made project. If you enjoyed what you saw here, make sure to go check out their other work on their ArtStation, including a series of process shots breaking down the project and how it was built. That's it for today's news and community spotlights. Thank you so much for watching, and we'll see you next time. Hello, everyone, and welcome back to Inside Unreal, a weekly show where we learn, explore, and celebrate everything Unreal. I am your host, Tina, and today with me I have the wonderful, the one and only, the been here a couple times, you might recognize him, Michael Prinke.
Pleasure to be here, Tina. Thank you for having me on yet again. This time I'm going to be talking about something a little bit more basic than the things that I've talked about on here before. We're going to talk about C++ and Blueprint. Which one should you use and when, basically? This is a question we get asked a lot, especially by new developers. And fortunately, to help answer that, if you'll cut to my screen for a moment, we have a brand new page on the documentation site for comparing Blueprint and C++, basically summarizing a lot of the information that I'm going to share with you today. I want to give a shout out to Chris Langley, one of the programmer writers on my team who did the research for this and wrote this page. It is very succinct, but also very informative, and links to a bunch of helpful pages for jumping between the two different environments. You can find this on the doc site under Unreal Engine for Unity developers, which also has a whole lot of new information in it. So if you are coming over from a different game development environment, this is a good place for you to start. Now, let's talk about what C++ and Blueprint are exactly, and a little bit about what's going on under the hood so that you can understand which one you would use and why. So C++ kind of needs no introduction. It is a well-used programming language throughout the software industry, particularly throughout the video game industry. It is compiled to machine code, meaning that it turns into a set of instructions that can then be fed directly to your processor. And it is object-oriented. That is an important point for C++ because C and a bunch of predecessor languages aren't necessarily object-oriented, depending on which version you're looking at. C++ really is kind of what a lot of people think of as the definitive object-oriented programming language. And the main thing that it gives you is you can define different parts of your program as objects. So you can define little discrete pieces that make up the greater program, and they each have their own job, they each have their own parameters. You can create instances of these different objects, and it is also polymorphic. So different objects can inherit from other classes. So you could define a class called animal, and it defines the basic parameters for an animal. Then you could define a class called badger, which then inherits from animal, and then that would have its own parameters, its own functions, and things like that. This is particularly nice when working in video games because we already think of games in terms of a set of objects a lot of the time. We think of playing pieces, we think of cards, we think of scoreboards, lots of different pieces that have different relationships to each other, different rules, and object-oriented programming works the same way. It's just very, very tightly enforced because it's programming. Blueprint, on the other hand, is a scripting language. It is not compiled to machine code. Rather, it is run through a virtual machine which interprets it and then sends it down to a lower level program to execute the logic that you are putting in. It looks a bit more like this, whereas in C++, the same logic looks like this. This is a quick little Fibonacci sequence thing here, which we're going to get into a little bit later. It's more visual, so visually oriented people tend to have a little bit of an easier time manipulating the nodes. And it is also a little bit easier to iterate in this environment because you can more easily change things. Whereas here you have to take a bunch of syntax and make sure that it transfers cleanly. Anytime you are cutting and pasting logic, here you can unlink one node and link it to a different node, and it's as easy as that. Plus, there's a whole lot of things that make it just faster to test and debug. Well, not necessarily debug, but definitely test things in Blueprint versus working in C++. And I'll get into some of those differences a little bit later. So to give you an idea of what the flow of logic looks like for executing these, C++ code compiles through a compiler, which turns it into machine code, which executes on the processor. Blueprint actually compiles into what's called bytecode. So this isn't the same as machine code. This isn't like a bunch of ones and zeros or whatever you think of as being really low-level machine code. It is rather condensing all of the functions and entities that you are working with into a series of addresses and index numbers. And then you can kind of condense it down to basically a big long number that tells it what it's supposed to do. So do action number 45 on instance number 72 of object number 106, for instance, would be a kind of an example of what bytecode might be like. Obviously a terrible oversimplification since Unreal is very, very sophisticated, but that is kind of the idea. There is a virtual machine running that then looks at this and interprets it, and then calls other functions in the program to do whatever job you're asking it to do. Now, the thing that people think about with C++ versus Blueprint a lot of the time is they'll say C++ is faster, and this is exactly why C++ is faster. It's because it doesn't have this extra step in between writing the code and then executing it. Everything in Blueprint that you write goes through this step and necessarily incurs a little cost. There's a little bit of extra overhead added to your function calls when you are doing this. Whereas with C++, it's already turned into machine code and doesn't have to go through that step. The thing being, C++, it should be known, doesn't just magically make your code faster. It is specifically this. It's not adding this to slow it down. And something else to know about this, the cost of running Blueprint through the virtual machine is not necessarily that humongous, at least not on an individual function by function basis. It definitely adds up with a lot of functions over time, particularly if you are calling a lot of functions at the same time. Then you are kind of compounding this cost on top of itself over and over and over again. So examples of places where Blueprint could hit that snag are functions that have to iterate through a list, like sorting algorithms. So if you write bubble sort in Blueprint, it will be much less efficient than bubble sort in C++. If you do recursive functions like the Fibonacci sequence, it will be much less efficient in Blueprint than in C++. That is just a fact of life, and there's no real getting around it. But otherwise, in terms of like 90% of the other things that you might need to do, like triggering an animation or a visual effect, or just changing the execution order of a bunch of functions you've written in C++, the cost of one Blueprint function at a time is so small you probably won't notice it most of the time unless you're really, really hurting for CPU performance, if that makes any sense. Let's see, what else is there to say about these? Well, that is kind of an overview of what's going on underneath the hood. The next thing to understand is the workflow of working with each of these. With Blueprint, if I want to make a new class, that is a definition for a type of object that can exist in Unreal Engine, I can click in the content browser in the editor, I can click actor, or whatever class I want to extend from, and we're going to make an actor that runs through the Fibonacci sequence. I've already got a test version of it here for reference in case something goes wrong. But basically, whoopsie doodle, I can open it up in the Blueprint editor. I can see a 3D view in the viewport of what my object looks like, what components are attached to it. Let's say I want to add a sphere, just so that I've got a visual of where the object is in space. And I can change a bunch of parameters here that represent the defaults for this object. So anytime you make an instance of it, whatever you've written in here, that's going to be what the default values are for its various properties. And then I've got the construction script. This runs anytime a new instance of this actor is created. And then I've got the event graph, which has a bunch of common events that can run asynchronous functions if need be. And then I can also add a function over here. This is a self-contained function that you can call in other functions or in the event graph, like so. And you can make copies of this anytime, and whatever happens inside of this is going to execute over here. And just to kick things off, I'm going to go ahead and write some logic for the Fibonacci sequence. For those who don't know about the Fibonacci sequence, it is a mathematical algorithm wherein the current value in the sequence is the sum of the previous two values in the sequence. So Fibonacci x equals Fibonacci x minus 1 plus Fibonacci x minus 2. And what I need to do first, because there is a special case to start this off, I need to create a branch. This is basically evaluating a condition for true or false. I'm going to do less than or equal to over here. And basically, if the value I'm feeding is less than or equal to 1, I should return a value of 1. That is the first value in the Fibonacci sequence. You have to do it that way, at least for this particular implementation. But I can make another return node just by copy pasting here, and I can then call my Fibonacci node. I'm actually going to condense this a little bit. I'm going to call it a pure function. It's also const because I'm not actually changing any values inside of this actor. So no other parameters belonging to the variables panel are changing. So this is a const function. And I'm going to subtract, create Fibonacci minus 1, and then another one for Fibonacci minus 2. This is what's called a recursive function. This is a function that calls itself. If you are relatively new to programming, you might look at this and go, wait a minute, isn't that illegal? And no, it is not. It is extremely legal, and it can be very useful for writing very succinct logic. This is notably not the most efficient way to write a Fibonacci sequence, but it is very demonstrative in that you can kind of benchmark with this and see how efficient or inefficient it's running. Now I'm going to go from false, so the value is larger than 1. It will go to this return value, and it will add the Fibonacci value of the two previous numbers. So basically, this is going to calculate the Fibonacci value of every number up until the one that we put in on this node, and see what that's like on the event graph. So if I put in a value of 10, it will do the Fibonacci of 1, the Fibonacci of 2, the Fibonacci of 3, 4, 5, 6, all the way up until 10, and it will add the previous two Fibonacci values together. And it will do this for every single one, which is why it's not the most efficient way of doing it. But again, our purpose is not writing something super efficient. Our purpose is a demonstration. Now, go back to the event graph. And I want to tell this thing to output each value in the Fibonacci sequence up to a certain number that I'm providing. So I'm going to add a variable over here, and I'm going to do num iterations. So now I've got this value. Click the little I symbol to make it public so I can edit it on an instance of this object. I'm going to do get num iterations and put that in at last index. Then I am going to print string, and I'm going to give it a duration of 15 seconds, just so it's got a long time to show the value on screen. And I'm going to build a string with two different integers. One is going to be the index number that we are currently looking at. The other is going to be the Fibonacci value of the index we are currently looking at. And I'm going to write, if this is hard to follow, it will be easier once I get this put together. Basically, I'm going to write Fibonacci of this value equals, and then this value. And I'm just going to put an empty space here so that it puts a space between this and the previous string. And then append string, put these two together, and voila, we now have an actor that as soon as it spawns in the world and runs this begin play event, that's the first event that it will run anytime it spawns, it will run through the Fibonacci sequence and print every value in it. And I'm going to put num iterations to 5, just so that we have a nice finite number to work with. You don't want to make this too large because integers can only handle numbers that are so large. And once you get into overflow, it's going to go pretty haywire trying to run this. This is not a very safe way of outputting this. I could put in a number like 100 and make the computer basically freeze up, or rather make the program freeze up. So we're going to keep everything under like 25 for the purpose of this demonstration. And now I'm going to go ahead and drop my Fibonacci actor in to the world, and now I have an instance of the Fibonacci actor. So Blueprint defines the object type that this could be, and now I have an individual instance of the object type that I've defined, if that makes any sense. Let's see here, and I guess there's nothing else but to hit play and see what it prints. So there we go. Fibonacci 0, 1, 2, 3, 4, and 5 gives us 1, 1, 2, 3, 5, and 8. Each one of these is the sum of the two previous values. So 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, and so on. And I can go into this instance of this object, and I can go to the num iterations value right here. Real quick, are people in the chat able to see this clearly? Because I did magnify my screen a little bit for this, but this could be a little small.
Let's see. Let us know, chat. Can you see the numbers and the stuff in the UI okay? I'm seeing, yeah, it's pretty good.
Okay.
They're able to see it okay.
So now I change it to 10, and we go all the way up to 89. So our Fibonacci sequence is working as intended. Again, if I were to put too big of a number in this, it would be a problem. I need to find a way of doing this that won't int overload if I'm to make this safe. But the worst thing that can happen is it gets hung up calling this function erroneously on numbers so big that it can't function properly, and then it just kind of freezes. It won't destroy the computer to have this happen, but you'll need to control alt delete out of it. Now, to real quick go over, what all we have done here, you can see that in order to access a list of the functions and variables that I can work with, all I have to do is right click. So if I want to get the value of num iterations or set the value of num iterations, all I have to do is right click and search it. I can set the actor's location. Let's see here, set actor location. There we go. And I can tell it to do a sweep by checking this box. That means that it will take the actor's collision and it will check all the points in between the locations where I move it to see if a collision should trigger. I can, let's see, destroy the actor, which means I am deleting it. I am removing it from the game and cleaning it up from memory. That is something I can do also. I have just this endless list of functions. I can search for different submenus of this and look up math, and I can see different Boolean operators. I can see different operators for working with color type data. I can do lots of things converting between different units. You get the idea. It is very, very easy for me to find the APIs that I need in order to do anything. And if I get a reference to another object, let's say this static mesh component here for the sphere, I can just click and drag the reference straight out of the variables panel, and I can change the static mesh just by click dragging off of here, and it brings up the menu, and I can search for all the functions I can access from this other object. If I do a collision, I can get a reference to the object that I collided with. Let's split this. Let's see here. And you can see the hit result struct, which you get from collisions, any type of collision, gives you information about where everything happened, what actor you hit, what component you hit, what kind of physics material was on that object. So I can get a reference to an actor that I hit and say, let's see, do any of the damage events still exist? Yeah. I can call apply damage and do damage to it. It's that quick and that easy. Once you get used to this environment, you can work almost at the speed of thought. Where things get a little bit messy is when you have a really, really extensive blueprint graph. So let's say that you've created a character for like an action RPG or something, and you have to initialize their inventory. So maybe you have to create a sequence and then call initialize inventory, and it branches off of that and goes up here. Then you have to initialize movement parameters. Then you have to initialize the model, initialize the current weapon, initialize down this line with a bunch of different branches that just turns into this big giant tree of blueprint nodes that gets really hard to navigate. You can, of course, make this easier for yourself by breaking it up into either separate events. So I might make initialize model right here and add like a parameter for the mesh that I'm supposed to use or something like that. And then I could call initialize model up here. And I could make this at least a little bit cleaner, or I could use a function to do it. Initialize mesh, input, grab a static mesh. And in fact, we are looking at like a reference to a static mesh from like the content browser here. So a soft object reference is advisable. Set the static mesh, resolve the soft reference, and there we go. And then this doesn't have to be hanging out in the middle of the event graph, cluttering up a bunch of space. It can just be its own little function and be all self-contained. Another thing about functions, the event graph doesn't have local variables. Functions have local variables. So you see this extra little tab show up over here in my blueprint. I can click this and add a variable. And basically, for the duration that this function runs until it completes execution, I can store things temporarily in this value. So if I had to do a bubble sort and switch to values in an array, I could temporarily store one of those values in this without having to make a variable for the entire object. It's limited only to the scope of this one function instead of being global to the entire object. And all this stuff is just kind of at your fingertips. But again, it can get a little hairy sorting this out visually once you get to really, really complex logic. Now, let's go over to the C++ environment and implement the Fibonacci sequence there. Let's see here, pull up. That's not the window that I need. That's the window that I need. So I'm going to go over here, and you can create a new C++ class in a very similar way to creating a blueprint class. You go to your folder for C++ classes in your project. You pick a base class for doing it. You can get a full list of all the classes you can extend in C++, which is much larger, you will find, compared with the number of classes that you can extend in Blueprint. I'm going to talk a little bit about that in just a little bit, but first we're going to make another version of the Fibonacci actor. I'm going to call it Fibonacci CPP. And over here, there's a little drop down that says Demo Project Runtime. That's the name of this project. But I can also pick different modules to put it in. This is one of the most important things that you need to know about if you work in C++. You need to know about modules and splitting your program up into multiple different modules. I'm going to go ahead and stick this one in test module. I'll show you all how to make a module in a little bit, but right now we click create and Fibonacci CPP starts creating. Got to reload my Visual Studio project. It's almost done. And now if I go into Visual Studio, I have a new class called Fibonacci CPP, which is represented with Fibonacci CPP.h, which is a header. This is like a big list of all of the functions and variables that exist inside of this class. And Fibonacci CPP.cpp, which is the file where I actually define the logic for all of my functions. So this is like your little address book, and this is like actually going inside of everybody's houses is a way to think of it. So right away, this is text. It is a lot more sensitive about the syntax you use. You have to put a semicolon at the end of every line. Many a newcomer to C++ is vexed by forgetting to put in semicolons. Now, let's define a function. int32 Fibonacci. And that just creates a function similar to what we did in Blueprint. I'm going to quickly create a definition. IntelliSense is not happy about this. Project 5 of 3, that's news to me.
I didn't know you could be Project 5 of 3, but
Oh,
here
now
we are.
it's 3 of 3. So when it's a new class, IntelliSense might not know about it too terribly well until you've compiled it once. So let's try this again. This time, looking for a specific thing here. I'm just going to try using that again. There we go. Now I've created the function in Fibonacci cpp.cpp, and I can proceed to write my logic. And that's going to be if value is less than or equal to 1, return 1, else return Fibonacci of value minus 1 plus Fibonacci value minus 2. So this thing right here in the header is the function's signature. This is what the program looks at to identify what information should go into the function, which is this bit right here in between the parentheses. That is effectively the equivalent in Blueprint of this input node. And then there is a return value, which is effectively the equivalent of this output node and the out value that I provided. You can make a function return multiple values effectively by defining out variables, which are basically values that you're going to fill in over the course of this, and then you output them as separate values in the parameters list. I'm not going to mess around with that right now. I'm just going to do this. But basically anything that you can do in Blueprint, you can do in C++. And you can see this was actually really fast to write compared with writing the logic in Blueprint. It wasn't by any means hard writing it in Blueprint because I already knew what to do. But this is just a much more succinct format to look at in a lot of ways compared with this node graph here that takes up a pretty good chunk of my screen. As a programmer, at least, it is faster for me to read this. And similarly, if I'm looking at some kind of like iterative function, like a sorting algorithm or something like that, it will tend to be easier to look at this. If I'm looking at something that runs off of a switch statement, so you feed in an enum or an integer or something, and if it's 1, then do this. If it's 2, then do that, that kind of thing. It is easier to look at that kind of information in this. But to give you an idea, the last time that I did this, I put in an int32 parameter called num iterations, like that, and I accidentally wrote, instead of Fibonacci value minus 1, I put Fibonacci num iterations, which means that this will eternally run the Fibonacci logic on this value because it's not updating for a new value that's being fed into it. So it's easier to make mistakes in this environment compared with Blueprint. What's more, if I want to get a list of the functions that are available to me here inside of this actor, let's say I want to move the actor to a new location, I can do something very similar to what I do in Blueprint, but I am depending on IntelliSense to do this. And IntelliSense can be a little bit ornery because our C++ code base is a little bit unusual. But I have to call this and then do a pointer reference to my own to the entity that I'm looking at right now, and then I can get set actor location, and then I get the function signature right here, and I can input all of this data that it requires to run this function. It can be a little bit of a bear having to look at this information, look back at this function signature all the time. You might need to have it open in a separate file. You might need to have it open in the API reference on our site. You might need to do any number of things to get a look at all the things that you're supposed to put in if IntelliSense isn't showing it to you. Sometimes I have to back it up a little bit just to force it to show the information that I'm trying to put in. One thing that's really, really nice is I can hit Control-Shift-F, and I can look for any instance of set actor location in the entire UE codebase and get a big list right down here at the bottom. I can see set actor location and rotation. I can see set actor location, set actor locations for this test utils here, which is doing it on a whole list. But basically, if I'm having trouble trying to implement this function, which can happen easily, especially if I'm throwing around a lot of delegates, because that's one of those things where I routinely look it up in our documentation, so I don't have to remember it. So it's helpful sometimes to Control-Shift-F and look for an instance where it has been used already in the code base and see an example of it being used effectively. And with the delegates, there are other parts of calling them that, not calling them, but rather defining them, that you can do wrong. You can use the wrong type of delegate really easily, and it will make it so that your code doesn't compile even though you think the references you're passing around are correct. So looking at the file where a function is used or where a delegate is used can be a way of figuring out, hey, what did they do to make this thing work? And you don't just look at the function signature itself, you look at the header for the file, the C++ file, and you see how did they define the log categories, how did they define the delegate type, what kind of delegate is it? Is it is it a multicast delegate, or is it an event, or all that kind of thing. Probably jumping way ahead talking about delegates for what this lesson is supposed to be. But that is an important part of working in C++. And whoops, I did not mean to Google something. Anyway. So the thing to understand here, this environment is perhaps less visually friendly at first blush. It is perhaps more tricky to find the information you need to write the code you need to write at times, but it is more powerful. It can be more succinct. It does provide more comprehensive debugging information. So to kind of show you how the debugging processes work between these two environments, this is a breakpoint. Over here, I can pick any spot in my code, and I can set a spot where if I'm debugging and I'm trying to run this function, stop executing when you reach here and point it out to me in my IDE so I know what's going on. I'm going to go ahead and let's see if I can attach to process here. Let's see, I'm forgetting where attached process is. Well, no matter, I'm just going to close the windows and build my code. I have gotten rather ahead of myself because this is a really important reason why scripting languages exist. what I just did was compile my code. And since my code base is really, really small, it took almost no time to do it. I successfully compiled the Fibonacci CPP actor in moments. But the problem is, as this code base gets larger, it will have to compile every single class that I define within the same module. So if I have 100 classes, all of those are going to get compiled. And it's going to take much, much longer than just compiling this one class. This is a huge productivity bottleneck for video games because basically you need to be able to test things and change them very quickly. Oh, and here we go. I'm starting up Unreal Engine. All I did was I hit the debug button up here. So it is launching Unreal Engine directly from Visual Studio. And you can't see the splash screen on my other screen, but I can. And now here it is. And I've launched a build that is now attached to this debugger. There's where attached to process is. Okay. So now I'm going to go into the code for test module, and I'm going to drop Fibonacci CPP. You'll notice it's invisible because we did not, in fact, add any model to it. That is another thing that is a little more challenging in C++ than it is in Blueprint. But I'm going to hit, well, if I hit play, nothing is going to happen because I haven't actually written the logic here to run through this on begin play, have I? So I'm not going to do that. I'm going to delete this, and I'm going to show you something else. Let's see. I'm going to create other things I've gotten ahead of as well, as a matter of fact. So I actually have to stop debugging. I apologize. I'm going to show you a little bit of the workflow going from C++ to Blueprint. Everything that you see in Blueprint is actually something in C++ that has been exposed as a Blueprint node. And we do that through use of, I do not need you to do that, through the use of the U macros. Not U property, property. Here we go. So this is the U property macro. This basically tells Unreal that this should be exposed to Blueprint. I should see it in the variables panel when I'm looking at a blueprint. It also, well, actually, I should see it anywhere. I should see it if I'm looking at an instance of the object and I'm clicking on it and I'm looking at the details panel. I should see it in Blueprint. But also, Blueprint should be able to read this value, basically get a reference to it, and also write to this value. Hello, Douglas. That's Douglas Adams. He is bored.
Additional surprise guest.
Additional surprise appearance by Douglas Adams. But not that Douglas Adams. So basically this says that it can retrieve this value and it can also store a new value in this variable. But also there is ufunction. This tells us that the function can be called from Blueprint. And in fact, why don't we do that and that? Oh, that's not going to work. Yep. Let's see. Try to remember where I put the constant here. Worry about that later. Let's just make this work. So Blueprint callable, it will appear with an execution pin so that you can control when exactly it executes. blueprint pure, it will make it a pure function. So it'll be this little node that is just called whenever it's needed. Now we're going to hit the local Windows debugger, launch Unreal Engine again. You see what I mean about how easy it is to forget to do things in C++. It's a lot harder to forget things in Blueprint because the nodes are already formatted for you. They already have the inputs and outputs and everything all set up for you. And it's just a bit more intuitive. But now I can derive this as a Blueprint class, and it will extend from that one. I'm going to call it Fibonacci extension. Why not? BP. Let's add the BP suffix so we know that it's a blueprint. And now I have something that is a hybrid of Blueprint and C++. And you can see I've got the Fibonacci pure function here. You can see it's a little bit cleaner than the one that I did in Blueprint earlier. And I can just take the logic that I wrote for the other Fibonacci actor and I can copy it over. Immediately have to add this value. Well, actually, I already have a num iterations value, so it's already there. This needs to be broken out. And there we go. Now we are calling the Fibonacci function that we defined in C++ instead of one that is defined in Blueprint. And you can extend all kinds of Blueprint classes off of C++ classes to build on functionality you build at the C++ level. You cannot go from Blueprint back to C++, unfortunately, because you just can't. But you can get references to Blueprint assets in certain ways in C++, getting them by name with certain functions in the asset manager. But you can't derive from a blueprint in C++ because everything in Blueprint that exists has to be built in C++ first. And yeah, anyway, it's a snake eating its own tail. So now we've got this. Let me make sure there's no additional Fibonacci's sitting around. I'm going to take this one and I'm going to change its text color to yellow. And I'm going to be a maverick and make its representation in the viewport a cube so that we know that it's different from the other one. And I'm going to take Fibonacci extension, drop it in, hit play. And there's our breakpoint. So it has hit the part where it checks if the value being passed through is less than or equal to 1. And you can see down here the call stack. This is a record of the various functions and variable references that have occurred on the way to executing this function. Now we hit return 1. Oops. And it did not run very much because we are still using 0 as the default value. Speaking of forgetting things. So let's switch that to 10, hit play, and we are still debugging. So we can hit this, and it will continually update the call stack. And it will also show me the value that is passed in to this function. It can watch variables and tell you what their current value is. So it's repeating. You can see down here, we've got 1, 2, 1, 5, 3, 1. It's just repeating the whole series over and over and over again. You can start to see why this is inefficient the way that it's written here, because it is repeatedly doing calculations for numbers we have already calculated. That is why this is really important to know how to do, because if you don't have this kind of insight, then you don't know what is costing you on performance. Insight, there's an interesting word. We might be getting into something having to do with that. And I am just going to remove these breakpoints now, hit continue, and let it finish. And now you can see it has calculated the Fibonacci sequence all the way up to the 10th place. So there we go. So that's a quick little overview of debugging in C++. And in fact, I can do a very similar thing here. I can't actually debug the inner workings of this function from Blueprint, but what I can do is I can set a breakpoint. Let's see here. Where's the breakpoint? Not break node links. There it is. I wondered if I was going crazy. Yeah, you can't add breakpoints to your functions, but you can add it to functions that have execution pins. So you can already see where the debugging starts to be a little bit more limited. Hit compile there, even though I didn't change anything because I'm superstitious that way. Now you can see the debugger hitting the breakpoint and showing us the flow of logic as it is occurring right now. Time is frozen, nothing is happening in the editor, but we can see what has occurred up to this point. And we can look at, well, ideally, we could watch values and see what is being put out for each one of these. There we go. So now you can see watching string return value, Fibonacci 0 equals. And as I hit this button, you can see that it updates and it shows what is going to come out of this node here. I can watch that value as well. And basically get at least some rudimentary information about what is going on. But I have no insight into how often this is executing based on what's happening here. So there are limits to the information that I can get out of this. But it is a nice visual format that can make it easier for some people who might find this a friendlier way of looking at things. So now I will just get rid of the breakpoints. Play. And there we go. Now, that is kind of a high-level overview of how the workflow between these two things differs. C++, in summary, very technical kind of environment with lots and lots of power behind it. Lots of visibility into the underworkings of the engine. The main thing being you get a lot more precise management of memory in C++ compared with Blueprint. Blueprint uses managed memory as a high-level language. The virtual machine does a little bit of work for you, cleaning up after you. In C++, you can define memory however you like without going through the garbage collector at your own risk. You can easily write for logic, which will result in memory fragmentation or which will result in memory leaks or things like that. It's this kind of thing where with great power comes great responsibility, but you get to decide exactly what is done with it, exactly where it is stored, and all that sort of thing. So you also have the opportunity to avoid memory fragmentation and memory leaks because you're paying such close attention to where everything is getting stored on the hardware. It is a little bit more meticulous to set up this environment. So you have to write a bunch of boilerplate code to make everything work. If I go into this module, if I want to attach an actor component to this, then I have to do create default subobject, and I need to know what class it is that I'm looking up for this sphere. If I wanted to add a sphere, I have to create a pointer to store this in. So I would put let's see. Use static mesh. If I want to use a class from outside of this class, then I have to either do an include statement up here to pull it in and have its code available, or I have to use a forward declaration like this, and then defer to including that logic here. And let's see if I can remember. Let's see, is static mesh.h the one I'm looking for? Let's search the Solution Explorer and see if that is a thing that exists, or if it's got to be like something more generic even than that. And that is a lot. That is a lot of things called static mesh. There it is, static mesh.h. I'm not as crazy as I thought, but I can't open it because it is in... Oh no, that's light mass. That's not what I need. Uh-oh.
Oh no, not the light mass.
Might be static mesh actor or something that I need to get, but I don't think that makes sense. Let's see if anybody, static mesh attributes, subsystem, compiler, editor module. This is a very lazy way of doing this. So lazy, I'm not even looking at the API reference. I'm just like, can I copy like Dave Ratty's homework somewhere?
If it works. I'm not here to judge.
At any rate, you have to, let's actually look for create default subobject instead, because we're a lot more likely to find the thing that we need in here. Let's narrow it down.
Looks like chat saying
static mesh
component.
That's why I'm doing this wrong. It's got to be a static mesh component.
Thanks, Kevin. Good chat.
And go. That makes a lot more sense. I forgot I'm working with components. I might be a little rusty writing gameplay code in C++, by the way. Just kind of the realities of my job and my new job title as well. So let's see here. There is static mesh component.h. panoramic capture, source, runtime, that's water, engine classes, components. There it is. Not components. There we go.
Listen, happens to the best of us.
Sometimes you have to provide a more discrete path to the library or a class that you have to include. This is one of those things in C++ that can become a little bit time consuming, is messing around with issues like this. Let me see here. What do I need to do other than looks like it's just that. There we go. That's the text macro. That means that this is going to be localized text rather than being a regular string. But that's just a little factoid there for you. Now let's see if that worked. There we go. We got a compile. And we hit the debugger again. And when we come back in, we should see this mesh defined in our blueprint that's derived from this class. Good example of what I meant by boilerplate. This is a little bit rougher to try and do as opposed to right-click add. Messing around with visual elements is not nearly as intuitive in this environment compared with in Blueprint. So we have a mesh. It is a static mesh component. We don't actually have a mesh selected, but we can pick one. No, I don't want to reopen the thing. Let's see, cube 1, why not? Pile, and now it is using a more different cube based on the static mesh component that we added in C++ instead of the one that we added in Blueprint. But I mean, look at how easy this is to do in Blueprint. I can just add a sphere because there's a preset thing for sphere. I can add a static mesh as a child and grab a sphere here. I can look at the viewport and see the sphere and move it around and see it next to the cube. I can make it like a little, almost like it's got like, need to change the scale here a little bit. Scale snap to 1. Good grief. Okay. Okay, I see what's going on. There we go. That's better. Make it look a little bit like it laid an egg or something. Placing objects in relation to each other is just so much nicer to do in this environment as opposed to in C++. Where you have to set all the coordinates manually and do it in code format and all of that. This, by the way, a Fibonacci CPP, : a Fibonacci CPP, this is the constructor. This is the equivalent of this in C++. So if I were to add a static mesh component here, set the static mesh here, and why not make it the axis guide just to make things really confusing. Now if I go over to the viewport, That's a sphere. Where is... Oh, something... Transform... Not relative transform. Go. Just default transform relative to viewport. Static mesh there. I should be seeing another static mesh appear, but let's take a look instead at... Yeah, there it is. So it has been added inside of the model. I can move the model, I believe, to fix that. There we... Nope. Never mind. That just moved the whole thing up because it's a parent of that cube. You're not saved from finagling what should be a parent of what. That's always going to be a battle in every 3D application that you ever work in or create. But you get the idea. This effectively does the same thing as this. It runs literally before everything else. Before you even begin play, the construction script is going to run. And you can do this, you can use this to do some really cool stuff, like make a blueprint that will arrange objects in a circle or arrange them in a scatter pattern or things like that. There's all kinds of technical art things that benefit from running the construction script that make level designers' jobs a lot easier. But anyway, I'm kind of getting into the weeds a little bit. Bringing this all back to the benefits and drawbacks of each workflow in C++ and Blueprint, because I have gotten distracted more than once going down rabbit holes here. So C++ is going to run more efficiently, provided that you have written code that is not a catastrophic misuse of memory. It is going to give you a more robust debugging environment, and it will give you a format that can be friendlier to certain kinds of logic, especially really math-heavy logic or things that you need to do with lists or switch statements or things like that. It is not going to be as intuitive to work with. It may not be as fast to work with, but it will give you a lot more power and control. Whereas going into Blueprint, stop that. I'm just going to open it up in... I shouldn't have closed the editor. I keep doing that. Blueprint will give you a more intuitive workspace that is especially more intuitive when you're working with visual things. It will add a little bit of overhead to everything you're doing, but that is worth it for the speed of iteration. And where that speed really comes from is the compile process. So when you compile C++ into machine code, it takes a long time relative to what it takes for Blueprint to compile to bytecode. It has to compile every file in your C++ code base, in the module that you are in. It has to, if you have done includes in your headers, you're kind of doubling up on the amount of time it's going to take to compile a given class, because before it can compile this header file, it has to compile actor.h's header file, right? And so that can compound, especially over the course of building a large game, to the point where anytime you want to change something in C++, you could take 30 minutes to a couple of hours before you're able to launch the program and see changes. We have tools to mitigate that, but it just isn't a problem in Blueprint because Blueprint just isn't that strict about how it has to compile. You only compile the blueprint that you worked in, the one blueprint that you worked in. And if it's inheriting from other blueprints, it has to compile, or rather, if other blueprints are inheriting from it, it has to compile those potentially as well, and maybe other blueprints that reference it. But that's less of a thing than compiling the entire library of classes every time you want to make a change. You're effectively compiling only the things that you have changed, whereas C++ has to get everything, and that makes it so much easier to, let's say I want to switch these two around for some ungodly reason and make everything make less sense. Look at that. I can do exactly that and instantly see it in the editor. If I wanted to change the fire rate of a weapon, if I wanted to change the logic for how a projectile travels through the air, I can instantly disconnect a bunch of nodes and connect them back up in a different way and see the change immediately. I don't have to wait. And that's the real reason why something like Blueprint exists, is to make iteration time on really design-driven kinds of things faster. So to summarize, where do you use each of these? I would use C++ to define the core systems in my game. Anything that is fundamental to the design of the game, anything that is going to be used very widely, that other actors are going to have to reference a lot, I would use C++ to do that. If I'm doing something with list iteration, I would use C++ for that. If I'm going to heavily rely on recursive logic, I would use C++ to do that. Anything that requires lots of repeated action, anything that is fundamental to the game's operation, that is just going to be used a bunch, and particularly things that are going to be really stable. That's going to be the best thing to make in C++, is stuff that you know once you get it right, you don't have to change it very much the rest of the course of development. So think of the inventory system for your game, which the player may be interacting with very, very often. Think of the base weapon class for your game, which may have lots of utility functions that all the other weapons in the game are going to derive off of. And then in Blueprint, that's where I would define individual weapons, different types of rocket launchers, different types of machine guns, or whatever. I would define a base item class in C++. I would define a potion or a health recovery item, maybe more generically, in Blueprint. And that would give me, as a designer, a lot of flexibility to mess around with this thing that players are going to get their hands on and use a lot, and help me refine what it's going to look like in the game, while I also benefit from a lot of the performance benefits of working in C++ and not having to go through the virtual machine to execute my logic. All of that to say just that quick summary. Base systems in C++, individual features / instances of objects in Blueprint, right? Or types or derivatives of objects, or things like that. Base systems in C++, content in Blueprint, I think, is a better way of summing it up. And there are ways of getting around using Blueprint to author content. Specifically, things like data tables. You can define a list of items in a data table and then write different effects and reference them with a generic item type of class, and just use this data to make whatever effect you need happen, and provide whatever assets you need for the item to do the things on screen that it's supposed to do. This is a thing you can do without ever having to touch Blueprint. It's basically an Excel spreadsheet. In fact, I can go down to this data table and export it as a CSV table. And if I like, I could also, if I have created a data table elsewhere, let's see here. Here we go. So let's say I've made this data table in a spreadsheet editor. I can download that as a CSV. And then I can click and drag that. And if I've got a struct to define the data table row, I can just import it. And there it is. There's the new data table. And I have here basically a little pipeline from working between Unreal Engine and a spreadsheet editor. And this can make design-driven development even more expedient, even quicker. Designers love spreadsheets. At least a lot of the designers I know love spreadsheets. Some may not, if they are really more about scripting. The other thing that you can do is you can create what is called a data asset. This is one of those things you can only do in C++. So there's a class called data asset. This is a really essential class to know how to use if you're making Unreal Engine projects. Let's see here. Call it Fibonacci data asset, put it in test module, make it private. Douglas, cut that out. He's trying to dig. He's a dachshund, you know?
He's digging to the truth.
Digging to the truth. I think he's telling me that he wants to go outside is what he's doing. So this is another thing to know about working in C++ and Unreal. Unfortunately, not everything is exposed to blueprints. You cannot make a blueprint of a data asset, for example. This is a type of asset that does not exist in the world, but rather exists in the content browser to hold information. So I'm just going to put the number of iterations in this data asset here, and then I am going to go ahead and recompile. I'm going to do a little something to make this slightly faster, though. I'm going to walk on the wild side and turn on live coding. Live coding is on by default. I turned it off because I was needing to what was I doing that caused me to turn off live coding? I don't remember. I might find out.
It'll come back to us.
So once live coding is on, I do have to restart the editor, so didn't really save myself that trouble. But I can do that. Open up demo project. Live coding is basically a system that lets you compile C++ without closing the editor. Unreal Engine is divided into different modules. So if you look in Engine here, you look in Source, and you look in Runtime, you can see all of these different modules that are built to do specific jobs or have specific libraries of functionality or specific features in them. If you go under Editor, these are all the editor modules. This is where all of the different types of windows and things and custom property drawers and things like that are all defined. Because I don't have to recompile all of these things in the editor, I can have the editor open, recompile the gameplay logic that I have built, and have that basically reload in the background while I've got the editor open. So if I hit Control Alt F11, live coding runs, and there's an error. Blueprint read-only should not be on private members. I need to remember to do this and make it public. Now we do Control Alt F11 again. This is that, has not been loaded by any process. Did it work, or is it no changes detected? Okay, that's concerning. Let me see if my data asset shows up. Let's see here. So data assets are here under miscellaneous, and there it is, Fibonacci data asset. So now, it has recompiled it, but it hasn't compiled it with the integer I just added. So I have to go back and make it recompile. Might not have saved my changes to this. Nope, it still thinks no changes have been made. This is probably why I closed live coding.
The chat, honestly, is almost exclusively crap talking live coding right now anyway. So
Yeah, well, look at me working against my own interests. Let's just open up the editor preferences. When it works really great. But when it doesn't work, it can be really, really aggravating. Mm-hmm. So let's close and build. A lot of people probably think I'm sacrilege for not hitting F12. I am very bad about keyboard shortcuts. And there we go. Fibonacci iterations worked. Now I can launch. Do. And now if I open up Fibonacci 10, there we go. Fibonacci iterations appears as a variable here. And I can set it to 10, which is what is suggested by that. I can open up my Fibonacci extension actor. Let's see here. I need... where the heck? Data asset. That's primary data asset. That's not what I need. Where the heck is data asset? Am I losing my mind? Because I know it should be here.
Those things do not have to be mutually exclusive, but
I suppose that is true. Let's scroll down a little. This is going to take forever. Okay, let's... You know what I bet happened? I did not define it as blueprint type. So it doesn't know that it's supposed to be visible in blueprint. So 12 is not the thing, I don't think. F11. See how bad I am at keyboard shortcuts? I thought it was F12. It's F11. Everybody knows that except me, because I cannot remember keyboard shortcuts to save my life. Incidentally, I'm very, very bad at real-time strategy games. Just atrocious. I'm mouse dragging everything. The amount of latency. I hope people are learning something from all of this.
Yeah, they're loving it. You kidding me?
Okay. Fibonacci extensions BP. Fibonacci data asset. There we go. And then
full faith.
I can go to this guy and I can plug in Fibonacci 10 and it will know that that is supposed to be, well, it doesn't know anything yet because it's not using this reference. Fibonacci iterations. So now this data asset that I am referring
Well, 1 second, Mike, if you can hear me. I think you may have froze.
Go.
There we go.
And let's hop back in and it will do 10 iterations. There we go. 10 iterations of Fibonacci coming from this data asset instead of from inside of the blueprint. So this is just another way that you can separate the data for your game from the code executing it. You needn't ever work in Blueprint if you don't want to, if you leverage the use of data assets and data tables to give designers a way of editing things without having to compile the game. These are really, really essential tools. But again, I have to highlight, you only can make a data asset type by going into C++. This is not something that you can make a blueprint of. So if I go to all classes, oh, no, it won't let me do it. I can't continue. I can do it for object. I can't do it for data asset. I can't do it for primary data asset. Primary data asset is another special kind of case. I will create one just to, why is it? What is going on? Let's see here. Miscellaneous, data asset. should see primary data assets somewhere in here. Ah, now why is that not showing up? Do I have to make a type derived from? No, I remember now. I'm being silly. I'm being very silly. Primary asset label. There it is. Primary asset labels. This is a useful utility for asset management in Unreal Engine. So let's call this items, or no, let's call it characters here. I'm putting it in the characters folder. You open this thing up, and you can see that it's got a bunch of information in it. It is a type of data asset, but it is a type of data asset that the asset manager will browse through when you are cooking your project. So when you go to hit build over here, there is a step of the build process called cooking where it takes and packages up everything into chunk files, or pack files, if you will, which are basically compressed files to contain game files in. What you can do is you can tell it, I want everything in this folder to be labeled for chunk ID number 10. And so now everything that is in the characters folder is going to have this label applied to it, and it will compile, it'll cook and be placed inside of chunk 10 instead of chunk 0 when I cook. And then it is up to me to load and unload that chunk when I need the assets in this folder. You can derive off of the primary data asset class, the primary asset label class, rather, to create your own offshoot of primary asset labels, which you can put your own logic in. So one really good example is Battle Breakers, a game we had on mobile for a little while that has a system with custom primary asset labels in it that not only keep track of the chunk that you are giving to this label, but also dependencies on other chunks in your game. And so its custom asset manager was able to keep track of an entire dependency tree of assets that you needed to have other assets. So if you had a skin for a particular character and you were trying to load it, it could automatically go up through this tree and see, I need the chunk for that character as well. I need the chunk for another skin that it's derived from, and so on and so forth, and then load everything without running into some terrible error that you would run into, like manually trying to designate which chunks should load. You know, that is a pretty deep cut for this kind of discussion, but it's an example of the kind of features that developers have to build in the background all the time, things that are not necessarily glamorous to build. It's not as exciting as building a weapon or building a character or what have you, but it is essential to make a game run efficiently and smoothly. In this case, it was there to necessitate a on-demand delivery of files over the air, because it's a mobile game. It was a kind of live servicey mobile game. So file size on your handheld device is a big concern in that world. You can't have everything in the game present all at once. You have to pull it on demand as needed. So when this character shows up, I will grab their assets, kind of thing. And that makes it a little bit more efficient to put the executable on the user's device. Just one example of one of the things that you can only do inside of C++, the kind of fundamental system you would not be able to build in Blueprint, or at least not very easily in Blueprint. And there are a number of other things as well. Data assets are one of those things you can't define in Blueprint, but also parts of certain plugins. The game playability system is one really big example where you have to define your base implementation of the game playability system and how it's being attached to characters and what your gameplay attributes are. All that has to be in C++ before you can go to Blueprint, and then you decide how you expose it to Blueprint. It's kind of up to you to know how you want to organize abilities in your own game, and then you create that workflow for the designers to work with. That's another way of thinking about this. Is C++ is for defining core systems and tools that you're going to build, core systems and tools that you're going to use to build, getting tongue-tied, core systems and tools that the designers are going to use to build the content in your game. And then Blueprint is the medium by which they use these tools. Let me see here. What else is there to go over? Let me see if I can get a hold of my Miro board. Oh, yes, setting up modules. So this is one last thing, the compile time issue in C++. You can get around this a bit. You can actually make compile times in C++ faster. And to do that, you need to organize your source code into modules. Here I have a module called Demo Project, which is there by default. That is the main gameplay module for my game. And then another one called Test Module, which I set up like 10 minutes before this stream started to make sure that I knew how to make modules. So if I open this in, give me a moment. So if I open the containing folder for this, what you'll see is I've got a couple of files here that are important. I've got a build.cs, a testmodule.cpp, and a testmodule.h that define the module for Unreal Engine. So I am just going to take and copy all that, make a new folder. This, unfortunately, does not have a handy-dandy project wizard type of interface for you to use. You have to do this manually. A lot of people I know make batch scripts or Python scripts to create modules for them and handle all of this busy work. But let's call this one inventory. Let's say this is the place where we're going to define the inventory for our character. So let's rename this. In fact, let's go a step further and call it inventory system. Rename this inventory system.build.cs. And then we edit these files. Talking about copying homework. Here we are doing it in Notepad++. I'm not even dignifying it with system. Log category. There we go. So the inventory system.h here is a file that defines not the inventory system itself, but rather the rather the code module that it lives inside of, if that makes any sense. The build.cs file is here to make it discoverable to the Unreal build system. So Unreal Build Tool is built in C Sharp, and it will iterate through all these folders and pick up any modules that have a build.cs file and use this to determine what other modules it has immediate visibility to. So thinking about the stuff that we had to do with where is it? Thinking about what we had to do with the static mesh component, I could take and add the components module here, and that should prevent me from having to do this thing where I have to have this folder path in order to do this. Now it will know that this module depends on the components module being present in order to work. A little bit of a double-edged sword there, but for the most part, including the modules from Unreal Engine itself is not going to be a thing that bothers your project. It's going to be when you have dependencies on your own modules that you have created, or your own plugins or other external resources. And if two things are very closely related to each other, you could get race conditions where one of these has to initialize before the other, but both of them think that the other one has to initialize first. And that can be a real problem and a half. But for the most part, you won't run into that, including Unreal Engine's modules. They necessarily have to be there before your modules are. But let's see here. So now that I've done this, now that I've put together my build CS and my basic header and CPP files, I have to go into the folder, go back up to demo project, and I have to edit the uProject file. The uProject file is not just something for the editor to pick up to know what project you're loading. It actually has information in it about how your project should load up, including which modules and plugins are supposed to be included. So we've already got test module here. I'm going to copy my own homework yet again.
If it's your own, though,
I mean,
it's fine.
You know. Inventory system, it is a runtime module, which means that this is going to compile for both the editor and for runtime builds or standalone builds or packaged builds, whatever you want to call them. The build that you distribute to the consumer, basically. Loading phase default. This is just the regular phase in which most gameplay modules load. And then additional dependencies, engine. I didn't actually add this. I think Unreal added this itself to correct me a little bit. But yeah, everything pretty much needs engine. Let's see here. Now that we've done that, I should be able to generate Visual Studio project files. And what this will do is it will regenerate my solution file. Whoops. I accidentally opened another instance of Visual Studio. That didn't need to happen. Okay, there we go. Hop back into Visual Studio, reload all, and now you see inventory system shows up as a folder. And I can edit the code here as I see fit. And better yet, And yeah, it's reporting a bunch of errors erroneously here. IntelliSense does get a little bit ornery sometimes. And what is going on here? Build errors. Would you like to know what is going on here? Let's try this again. Oh, did I put this in a silly place? Did I see test module build.cs? Nope. What is it thinking? Well, I seem to have broken everything.
Oh no.
That's never happened before.
That's definitely not something that anyone else can relate to.
All right, well, I should be wrapping this up anyway, but let me just, you know what? I've got a quick solution to this. Get rid of that. Get rid of that. Now I don't have to worry about that. What have I done? I seem to have broken static mesh actor everywhere.
Oh no.
How did that happen? All this from creating this inventory system. This is the only thing I can think of if I picked the wrong name for that. One more time. And now it's going a lot more smoothly. Never mind.
Someone said components in the main build file.
Test module.h, no such file or, oh, because an inventory system, yeah. I forgot to change a line here. Whoops. Let's see here. Try again. There we go. Much better. And I know we are short on time at this point.
Oh, you're good.
Right, running Unreal Editor again. There is one last little thing that I want to show off, but now you see the cube is gone because I got rid of the mesh, but I didn't need to do that. Let's see here. What was I going to do again? Oh, right. Make a new C++ class. Let's make an actor and go into inventory system. And now this is available for me to create C++ code in, and it will be separated into the inventory system module instead. So what this does for me, aside from being a really neat way to organize your code, when you change code in this module, it does not affect code in this module. That's the benefit. That is the way that it mitigates the compile time issue. So if I change code here, it will only compile this module. It will compile all the code that is in that module. So I don't get out of compiling a bunch of other stuff potentially that I don't need to, that I shouldn't need to compile, but, or rather things that I haven't changed. There's a lot of reasons it might need to compile, but even though I don't get out of that, I do get out of a lot of bloat that can happen in the compile time. And that can make C++ a lot more expedient to work with. So that's a good way of mitigating this without needing to rely on Blueprint exclusively for mitigating your compile time. But one thing that one thing I will note is I mentioned classes that you're going to change very frequently. There is another perfectly valid use case for blueprints, and that is prototyping. So if you don't know exactly how your system is going to work that you're building, it is a perfectly valid thing to build it in Blueprint first and then bring it back down to C++ and create a C++ version of it once you know the logic that you need to write. This is something that I know a lot of indie developers do. It's something that I do in personal projects when I make them. And to show you a little something that will help out with that, let's go to the Fibonacci actor, the one that is just purely built in Blueprint. And if I go to Window, let's see here, where is the preview C++ header? So asset preview equivalent C++ header. What it will do is it will spit out a header file with all of the function signatures that I need and all the variables that I need to replicate the functionality that's here. And I can literally just copy paste this into an empty C++ header file and use it as the basis for building this class in C++. So that's a little shortcut. And there's also a menu here that will let you explore all of the various different Blueprint classes that you might do this with. I'm not exactly batting 1,000 finding ones that have lots of stuff in it. There we go. So if I wanted to transfer linear velocity for cloth into C++, I could do that. Whew. And then there is one last tool that I want to show you that is essential for all programmers and that I want to make a demonstration with, I hope. So let's open up the Blueprint Fibonacci actor, add a delay of 2 seconds. This one will run after 2 seconds and it'll output all of its text in blue. And then we'll go to Fibonacci extension. And make that a delay of 1, and it'll output in yellow. Now, down here, this is stuff for working with Unreal Insights. If you are making, if you are using a build from the Unreal Engine, the Epic Games launcher, you will already have Unreal Insights available. If you are using a source code build, you are going to have to find the Unreal Insights project in the Solution Explorer for Unreal Engine, and you're going to have to compile that project. And then you will get Unreal Insights. But what Unreal Insights is, it's a profiling tool. What I can do is I can record my gameplay session, give it a couple of seconds, there we go. And now it has run the Fibonacci sequence on both of these. I'm going to make this one actually 10, and I will also make this one 10 using the data asset. This is going to muddle things up because these are not equivalent implementations, but so now I run it. That one does 10, that one does 10. I'm going to run around a little bit. And then I will stop tracing. And now when I look in here under recent traces, this will be the most recent one. I click on it, and it will open up directly to the Timing Insights window, which shows me information on the CPU and GPU performance. This is critical for determining your performance. And what I can do is I can click in this timeline here. These are the rendering frames that are occurring during my editor session. And you can see they're numbered by the frame. And it'll tell me how many milliseconds it has taken to run this frame. And if I look down here, zoom in a bit, I can see which functions are taking up the most time. So these ones that are longer, that have longer bars, they're taking up more time, and ones that have shorter bars, these ones that are minuscule in particular, are taking up way less time. You can see that we are on the sub-second level by a pretty good margin here. And if I look over here, oh, yep, 200 nanoseconds inclusive time. Yep, that one's doing pretty okay. But let's go to this frame here that has a big spike on it and take a look at what is responsible for all of this. And we've got F-engine loop tick, we've got frames, so that's going to be, I think, some rendering related stuff. Hitching. This is just straight up a processing hitch that occurs. Let's see, wait for tasks, RHI. I'm looking for a specific thing. I'm going to go into the timers window here because let's see. What is going on here? Let me pick on this. There we go. There we go. So you can see a list of all of the functions that are happening on this frame that I've selected, which has a 329 millisecond duration. And which ones are taking the most time. So we've got a wait for tasks here, which is not super helpful. We've got some stuff for drawing frames, drawing the UI. What I'm looking for is any information about my Fibonacci actor. There we go. So Fibonacci extension BP is running fairly well, it looks like, which is not super helpful. I'm really looking for it to tell me that it's taking a lot of time. Well, this isn't the demonstration I thought it was going to be. Gosh darn, the one thing I want, the one time I want it to work poorly. Oh, there we go. There we go. Execute Ubergraph Fibonacci extension BP. Okay, so back here. Okay, so this is the blueprint functions for executing the Fibonacci sequence, it looks like, which still are not the really nasty ones as far as the direct profiling data is concerned. I should come back to this when I have learned a little bit more about how to make it do something slow. Fibonacci extension BP.
It's just too efficient.
Anything. Unreal Engine, it's just too efficient. You heard it right here, folks. So efficient, I can't make it show a severe processing bottleneck that easily. I mean, there's clearly something going on here every time it runs the Fibonacci sequence. with my terrible recursive function, right? Clearly, these are big spikes in processing activity where it suddenly takes longer than 100 milliseconds to run. But it's not as straightforward as I was hoping to point out the blueprint function versus the C++ function and say, there it is. That's the one that's doing it. So I'll need to do a little more research into this. But in the meantime, this will give you an idea of what the basics of working with Unreal Insights is like. And let me see if I can actually find this here. No. Nope. Go. Darn. Go. Highlight event. Plot timer. It is already plotted to the main graph. So the main graph shows where this event has its spikes. Those correlate pretty nicely to the frames window up here. And it shows you how much time that specific process took up. So we are getting something. Just not as definitive. 80 milliseconds, I guess, is pretty nasty there. But all right. I think this is where I had better call it if we're going to have room for any questions. So are there any questions that I can answer?
Yeah, there's a few. A lot of them, honestly, you also just kind of naturally answered as you were going through the steps of your demos, but there's a few here that I definitely want to make sure that we ask. One, so back when this was kind of near the beginning of when you were showing stuff, when you were setting up the Fibonacci in Visual Studio, and you mentioned the brief infinite loop you had accidentally made. There was a question of, would the infinite setup act worse than on the tick?
Would the infinite setup act worse than on the tick?
Mm-hmm.
So if I understand the question correctly, what they're proposing is to do Fibonacci iterations each tick. And then, okay, so the problem with the way that I set it up and that accidental infinite loop, it would not matter because it was not actually reading in the iteration number it was supposed to be doing. It was reading in the number for the maximum number of iterations that it's supposed to do. And so it never actually finishes running the Fibonacci sequence. So if you did that on tick, then you would theoretically do it every frame. But the problem is that it will freeze the very first time that it hits that. It will hit basically an infinite loop error, stack overflow, that's what it is, and it will just stop dead in its tracks anyway. So both ways are terrible.
The answer is don't do either.
It's the same problem. Trick question.
Fantastic. All right. The next question here was, someone was wondering, what tools do you mean would speed up the compilation process using C++ in Visual Studio? If you have
that was the modules setup. That is setting up different modules for different parts of your program. I showed you how to do modules in your project. You can also actually go to plugins and you can create a new plugin, and plugins actually have their own self-contained modules as well. In fact, you can add modules to plugins because plugins are kind of like a modified, stripped down version of a project, if that makes any sense, a UE project. So .u plugins are like .u projects, and they can refer to multiple modules if need be. But this is the fast, easy way of getting a module into your project if you don't want to do the manual copy pasting work that I just did, or if you don't have a script. Either one of these, the more you break up your code into discrete modules, the faster compilation goes, because you don't have to compile things outside of that module when you change the code in it. So if I've got an inventory module and it's got the base item class and the inventory class, and maybe handheld object, for something that it sticks into the player's hand or something like that, and maybe item effect to define, what items do when you use them, or consumable item effect would be a better name. If I change consumable item effect, it doesn't then also recompile my character that's in the main game module. It only compiles inventory, consumable item, and all the other classes that are with the inventory.
Very nice. Let's see. Next question here. And this one is definitely more of what is your opinion on this? Of course, there's not technically any correct answer, but do you feel that programmers would benefit from using blueprints as much as C++, or do you feel blueprints are more so suited for designers?
I feel that whatever environment you are the most productive in is one that you should definitely leverage to your advantage, regardless of whether you're a programmer or a designer. I know some programmers who are super comfortable with blueprints and who do prototyping in blueprints for fast iteration, and then they move things to C++. I also know programmers who are very persnickety about the potential issues with the visual organization of blueprints, and who are more comfortable working in a more traditional setting with a text editor. And they will, always use that. If you feel like you are just as productive in C++ or more productive in C++, use C++. If you feel like you get faster results and hone in on what you need to build quicker working in blueprints, work in blueprints. The ultimate decision of which one is right comes down to what is right for the thing that you are building, more so than a philosophical issue of which one is just flat out superior. Different people's brains work in different ways, and in terms of how I think they are best employed, I've given my opinion on that. It's use C++ for base systems and base versions of objects, and then derive off of that in Blueprint, and kind of use the things you define in C++ as tools for the designers that you're going to give to the designers to build the stuff in the game that they want. I'm very much in favor of a symbiotic relationship between programmers and designers in that way. But there are some things you can't get around. I talked about a lot of things in C++ that you can only do in C++. I didn't talk about user interfaces, which I wanted to get to. UMG is really a much better way of working with user interfaces for your game or your application, whatever you want to call it, than trying to program your user interface in Slate in C++. It gives you access to motion graphics. It gives you a way to visualize your user interface. It just is going to make your life 8 million times easier. And that's the other thing, technical artists. We didn't talk about artists alongside designers. Technical artists benefit immensely from working in Blueprint and learning a little bit about working in Blueprint, and it will give them most of the functionality they need. What it won't give them is the ability to write shaders. You can write materials. Materials are not the same as shaders. A material references a shader and uses a shader as its base for how it computes lighting and shadowing, but ultimately a material is like a derivative off of that is a more high-level construct. And shaders are written in C++, and they are meant to be highly optimized. because you're using them all the time. There's that pattern again. If you use it all the time, it should be C++. I hope that that's an adequate answer to that question.
Absolutely. No. The worst answer ever. Yeah, of course. That was great. All right. The last question I want to go over now, otherwise I don't want to take too much of your time. You've already spent so much of it going through all of this with us, which I appreciate. So the last question I have for you is based around documentation, especially because, as you said, there is documentation specifically about Blueprint versus C++ now available as well. There were some questions on if there are other sections of documentation that is dedicated to just blueprints or C++, and if so, where they can start, where they can find all
that. There are sections dedicated to Blueprint and C++ specifically. So I will bring up my screen and open up Unreal documentation. Make sure, by the way, if you're working with UE 5.4, make sure you're on the 5.4 version in this dropdown. You have no idea how often I get somebody coming up to me and going, hey, I think the documentation for this thing is outdated, and it's literally a document that I just wrote for this version. And then I find out, oh, they had it set to 5.1. No wonder. So that's a good thing to keep in mind. There is a programming and scripting section with a section for C++, and a section for blueprints. This will give you introductory information on using blueprints, a few tutorials for working with specific things about the blueprint interface. The C++ section has information on using delegates. This is the thing that I was too scared to try and type in front of you, so I chickened out. Yeah, dynamic delegates and multicast delegates, they're all listed here with the convention for what parameters you can feed into them. We've got the coding standard here, which tells you basically the conventions that Epic Games uses to define, to write code, what it means to write code that is consistent across our organization. We find that a lot of these things work well for us. They might work well for you too. And there are other things outside of these two sections. Oh yeah, C++ has the Slate UI programming section as well? No, it doesn't. I changed that in 5.3 or 5.2. That's going to be under creating user interfaces, which is right here. So yeah, Slate stuff has been moved into the section for user interfaces alongside UMG, just so you know. Seemed like the thing that made a little bit more sense. Under C++, let's see here. Let's see, class creation basics. This is a walkthrough of how to make a new C++ or Blueprint class in the wizard. Let's see. Unreal architecture. This one is a really enlightening section to look at because it's got a lot of information about kind of what's happening under the hood inside Unreal, if you'll forgive the pun. And then we've got development setup. This is a section for all the different IDEs that you can work with. Let's see here. That is troubling. Okay, no, it's not. Visual Studio, Xcode, and VS Code all have documentation here. We want to get Rider in the near future as well. We are compatible with Rider, but that's where you'll go to set up your development environment. Just so you know, this bears mentioning, we're not super happy with the table of contents and the way that it's organized, but for a lot of technical reasons, right now, changing this table of contents is a terrible process that will create lots of dead links if we are not super meticulous about it. So we have to keep it this way until some things about the tooling change. But we are aware this is not the ideal way for this to be laid out. We're going to break some of these out in the future into top level sections so that it's easier to find. But aside from that, making interactive experiences, this is basically the blueprint and gameplay programming section. This is all about working with various different subsystems in the engine that are conducive to building gameplay with. So the physics system has a section, AI has a section. We've got some stuff for gameplay abilities, although we keep meaning to improve it. Data-driven gameplay is also potentially very helpful. That will give you a lot more information about working with data tables. You get the idea. Input, working with the input system. In fact, enhanced input is a really big one. This is what we prefer going forward as our default input system for determining, how your controller actions map to actions in game. You get the idea. Oh yeah, and of course the gameplay framework. This should be a primer that everybody reads before they get started programming gameplay, because it goes over the game mode, the pawn, the player controller, game instance, game state, all of the different classes that are there by default when you start building a game, and what they can be useful for when you are working here. This is one of the snags people hit when they're new to Unreal that can really intimidate them. There's so many of these different classes. How do you know the right place to put your logic? I'll tell you a secret. The right place to put it is the place where it works. As long as it works, it's not necessarily wrong. But some of these instantiate at different times, and some of these will persist in different ways during network gameplay in particular. That is the reason for game state and player state, as a matter of fact. These are helpful classes for network gameplay that they're like ghosts floating over your body, so that when your character dies and respawns, you don't lose information that you might need to carry over. Things like your current scores or things like that. If you put that in the pawn, that's liable to be a problem, because you'll destroy the pawn and then you'll get rid of all that information with it. But anyway, those are the places where I would start. And then you go down to testing and optimizing your content. This will have the documentation on Unreal Insights. You can read this thoroughly and then hopefully make better use of it than I did during this demonstration. It is a very, very useful profiling tool, and I'm sure I did not do it justice. But basically, this will tell you about a lot of optimization tools that are at your disposal. It will tell you about the different stat commands that you can use to peek at your performance metrics. It will tell you all about using different file formats, using Zenloader. We have stuff for Clang sanitizers, which is really more of an Android and Linux kind of thing than anything else. And a little bit about our test framework here as well. The automation test framework can be very, very helpful for setting up your debugging and testing pipeline for your organization. And then finally, was there one more thing? Setting up your production pipeline is basically all about creating tools and defining workflows for your organization. How you can deploy Unreal Engine to your organization, how to use multi-user editing. Virtual assets is here. This is a really helpful feature for keeping your hard drive usage slim for your project. But also there's information about editor programming here. So all of the stuff for using Python in Unreal Editor. We do support Python. It is not used for gameplay programming. It is used for development pipeline stuff. But we also have the Slate Tools programming section, which I've been steadily building out. And let's see, are there any others here? Yes, the blueprint scripting. So using editor utility widgets and scripted actions are right here. So that is an overview of all the docs that will help you out with programming. And then, of course, creating user interfaces for anything UMG and anything related to basic usage of Slate.
Awesome. So there's tons to dig into. Make sure that y'all go check it out when you have the time and the chance to do so. Lots of work has gone into getting all the documentation set up and also just like compiled into one place. So make sure you go check it out and enjoy. But other than that, I think that's a good place for us to stop for today. So first of all, thank you so much, Mike, for coming on today and chatting about this with us and showing us all this cool stuff.
It is my pleasure, Tina, as always. I hope that I did right by all of you.
Absolutely. Absolutely. Yeah, so also thank you everyone who came to watch. The show wouldn't be what it is without you and your participation. The chat today was particularly lively. Y'all were making me laugh a lot. They were in great humor. It was a great time today. So thank you for coming and hanging out and being part of this whole experience as well. If you missed any part of the stream, don't worry, because we post all of our streams in video format that can be viewed on demand on both our Twitch and YouTube channel. So you can go back and reference any part of this at a later time if you need to, or if you missed any part of it, you can always check it out then. If you have further questions or suggestions as well, make sure that you put them in the comments on the YouTube version of the VOD, just so that we have access to it. We can see what y'all are wondering and what else you'd like to see from us in the future. If you want to keep up with the latest news, see everything that we're up to, events that are coming up, Unreal Fest is on the horizon. There are still tickets available, so if that's something you're interested in, check that out. But you can learn more about all that kind of good stuff on all of our socials at Unreal Engine. And also, if you're not already, you should definitely come and join the Epic Developer community. That's where we have our documentation. That's where we have tons of tutorials. That's where we have our forums. It's where pretty much anything you could ever need related to Unreal Engine is available right there in one nice little succinct package. So go check that out if you haven't already. It's a great little place, great community there. Love being able to just dive in and see what people are working on and see people helping each other. It's really nice. So make sure you enjoy that. And then the last bit, some of y'all may remember that there was supposed to be a stream about 5.4 rigging and animation updates, and that unfortunately had to get moved just because of some extenuating circumstances, and it's been moved to next freaking week. So tune in next Thursday if that is something that you're interested in, and you should be, because it's cool. There's a lot of really cool stuff that they've got lined up. That team has just amazing stuff to show all of the time. So make sure you come back next week for that. We'll see you then. But in the meantime, I hope you have a fantastic rest of your week. Enjoy your journey on development, and hopefully you learned something fun that you can use today as well. Bye, everybody.